Hello everyone. Today we will discuss this very famous Google interview question, alien language. So basically, we have given a set of words of the dictionary. These are the words of a dictionary. So definitely these are in a sorted order, and we have to find the order of characters in that. For example, these three are the words CAAA, and second word is AAA, and third word is AAB, and output is AAP. So let's understand this first. So CAA is my first word, and my second word is AAA. So now if I compare these words, right, C and A. So this is my first word of the dictionary and this is my second word of the dictionary. So definitely if I compare C and A, A is the first word. So A comes after C, right? And rest all are same. And now let's compare second and third word A and B. So these are same and A is the second word and B comes in the third word. So A comes before B. So if I combine these two, right? So this is my output C, A and B. So now now what we have to do is we have to write an algorithm to find out the order of characters. Okay, so now let's think about the information which we have in this question. So we have given a set of words and we have to find the connection of the characters in that word and that's all. Like if you see, right, C points to A and A points to B and we figured out the order. So what uh, what if we take what if we consider each of these character as a graph node. For example, C is my one node and my second node is A and third node is B. So let's pick up as we did this thing manually, right? Let's do that again. We'll pick two words at a time and we'll connect this the nodes of the graph. So we picked C, triple A, right? We compared C and A. C comes before C comes before A. So that's what it's a directed edge. That means A can come only after C, and we compared second and third word, and we figured out that A comes before B. So this is the directed edge. Okay. So now we have a graph, and what we have to do is we have to derive the uh, order of vertex from that graph, right? So if you know about the graph sorting algorithm, so TopoSort is the one which can help here. Basically, that is basically to find the order of vertices. For example, so I have covered the TopoSort in detail in my last video. So I suggest you to go through that. I'll just briefly cover briefly touch the TopoSort here. So the funda of TopoSort is if a node have any neighbor or adjacent vertices that should come after that vertices. For example, C, right? C has one vertex A, neighbor vertex, so that basically should come after C. And similarly for A and B, A as its direct edge points to B, right? So A should come before B. Basically, if a vertex will appear only only before all its neighbor vertices are processed. For example, if let's say D is here, right? So A should come before all its neighbors. For example, B and D are the only neighbors, right? So A should come before B and D. And let's say C has one more neighbor you call F. So F should come after C. So this is the topper sort. So just go through my previous video and let's come back to this question. So there are two main, if we divide this problem into two sub-problems, right? There are two problems which we have to address. First, we have to find the connection between these two words, and second, we have to find the connection, and second is we have to create a graph we have to create. And second problem is this once we have a graph, we can just um, do the topper sort. Okay, sorry about very bad handwriting. So let's quickly go through the code I have pushed in my GitHub account, so you can go through that. And yeah, so if you have any comments regarding this code or about this concept, so just add comment in my video. I'll try to address that. Okay, so what's the input we have given is set of words, and first we have to figure out the order of the words, right? So as we were doing manually, right? What we were doing, we were picking two words at a time, right? That's what this method is doing. It's picking ith word and I plus 1th word and comparing both. It's calling some compare method. What compare method is doing is simply it's iterating both the words till word length. Like for example, there are two words, word 1 and word 2. M will go M this while loop has a condition, like this loop will run till m less than word 1 length, and n will run till word 2 length. And what it's doing in the loop is it's checking if word is not same, like if this sorry, not word, if it's comparing this it's comparing these characters of word 1 and word 2 and checking if it is same, then just ignore that, and if it is not same, just add a edge in the graph. Checking if word is not same, it will just continue, move to the next word, next character. And if a character is not same, it will just and if there is no edge already, if C and A are these are not same, and if there is no edge already, if it's not connected, just add this edge. That's what this is doing. And once these graph is created, these edges are added, what you have to do is just call g dot graph dot topological sort. And for topological sort, there are two methods written, topological sort, and this is the like calling this recursive method. For topper sort, this code is also covered in my previous video, so you can check there. That's all. Yep, that's all. Thanks for watching. Thank you.